Dear students, we know that every object on the earth attracted by earth towards its center. Not only earth, uh, every massive object attracts the other massive object on the earth, not only on the earth, in the universe. You know well that the sun always attracts the earth, and earth is also attracts the sun with the equal amount of force, and that attracts the moon, and moon is also attract the earth with the equal amount of force, and the sun attracts moon, and in the same way moon is also attracted sun. If a small pebble is there on the earth, this is attracted to earth with a force F, then earth also have the same force on the pebble, means the forces are equal. Then you may get a doubt that when the forces are equal, why the small bodies are moving towards earth, why the earth is not moving towards the small bodies? Because the mass of earth is more and the mass of the pebble is very less, or mass of any body is very less compared to the mass of the earth. So as the mass is more, the forces are constant, then acceleration of earth will be very less compared to the acceleration of the body. Let's explain it clearly. The force of earth on the body is equals to force of body on the earth. So this is earth on the body, so it is given by the mass of earth is taken as capital M and its acceleration as small a, and this is the mass of the body is small m and its acceleration is let it is capital A. Now as these two are same, the mass of earth is very much more compared to the mass of the body. As these two are equal, then the acceleration of earth will be very less compared to the acceleration of the body. I think you understand my point. By this the acceleration, as the acceleration of the body is more, it gets accelerated towards the center of earth. That's why there will be movement for the earth also, but it is negligible. So the body only moves towards the earth. Newton has given a relation between the two bodies which are having masses m1 and other is having mass m2. These two are separated by a distance of r, and according to Newton, F proportional to m1 m2 means F is directly proportional to the product of masses, and F is inversely proportional to the square of the distance between them. By combining these two, I can write F proportional to m1 m2 by r square. So this can be written as F is equals, to remove the proportionality and to keep is equals, I have to keep a constant which is called G, universal gravitational constant, and m1 m2 by r square. This is the equation given by Newton, but he had not given any value for G. After his death, Henry Cavendish has given the value of G as 6.67 and to 10 power minus 11 Newton meter square per kg square. This Newton meter square per kg square is the unit of the universal gravitation constant. You need not to by heart this. You have to, you must be in a position to derive the units based on the formulas. We have F is equals to G m1 m2 by r square. This is the formula. From this, G can be written as F r square by m1 m2. So F, the force is measured in Newton in SI system, and r is the distance between the two bodies which can be measured in meters. So it is meter square per mass. Mass is measured in kgs in SI system, and kg into kg which is equals to kg square. So this is the unit of the universal gravitational constant. Now let's find the relation between the acceleration due to gravity G and universal gravitational constant capital G. For this I am considering a body of mass small m falling from certain height onto the earth. Then I can give expression for this like this. If capital M is the mass of earth and small m is mass of the body, so F is equals to capital G, capital M mass of earth and small m mass of the body, and here the distance between these two. Here the distance between these two means the distance from here to the center of earth. The radius of earth is very large compared to the distance between the body and the surface of the earth. Okay, so by this we can neglect the distance between the body and the surface of the earth. So I can take the distance between the body and earth as the radius of the earth itself, and it is equals to F is equal to G capital M small m by r square. Okay, now we have a formula. F is equals to ma is equals to G capital M small m by r square. Here the acceleration can be replaced with acceleration due to gravity, because this body is freely falling from certain height. The acceleration of a freely falling body is called acceleration due to gravity. So this equation becomes mg is equals to G capital M small m by r square. Here small m represents the mass of the body and capital M is mass of earth and r is the radius of earth. G is the universal gravitational constant and small g is acceleration due to gravity. I can cancel these two and the equation becomes G is equals to capital G capital M by r square. I am going to find out the value of G on earth. So for this I have to substitute the values. G is equal to 6.67 into 10 power minus 11 Newton meter square per kg square, and mass of earth is 5.97 into 10 power 24 kg by radius of earth is 6.37 into 10 cube kilometers. As all the values are taken in SI system, this kilo should be replaced. Kilo means 1000, so I can write this as, instead of kilo, this is 10 cube. 1000 means 10 cube and it is whole square. Now the value of G is, by multiplying 6.67 and 5.97 and dividing it with 6.37, I am getting 987 into 10 power minus 11, this is plus 24, and here 6 and 2, so it is 12. So as here it is plus 12, it moves to the numerator, it will become minus 12. It will become 10 power 1. So this can be written as G is equals to 0.987 into 10, which is G is equals to 9.87, and this is meter per second square. So this is the value of acceleration due to gravity on the earth. Solve some problems on Newton's law of gravitation. Here one problem is given: what is the force of gravity acting on an object of mass 2000 kg at the earth's surface? So mass of the object, that it is MO, is equals 2000 kg, so it is 2 into 10 power 3 kg, and mass of the earth, it is 5.97 into 10 power 24. For my convenience to have easy calculation, 5.97 can be taken as 6, and it is 6 into 10 power 24 kg. And the distance between the object and earth, the object is on the earth, so I can consider the distance as the radius of the earth, which is given by r is equals to 6 point something, so I am taking it as 6000 kilometers. 6000, 6 into 10 cube, kilo means 1000 again, so 10 cube meters. So this is the radius. So I have a formula, F is equals to G mass of earth, mass of the object, by distance square. Here the distance is radius of earth. Putting the values, F is equals to 6.67 into 10 power minus 11 into mass of the earth, that is 6 into 10 power 24, and mass of the body, which is equals to 2 into 10 power 3, by radius. Radius of earth is 6 into 10 power 3 into 10 power 3. It's square. Square means we have to write again 6 into 10 power 3 into 10 power 3. This 6 gets cancelled, and 6 ones are 0.6 ones are 6 ones are. So it is F is equals to 1.11. Here we have 2, so 2.22 into 10 power minus 11, 10 power 24 plus 3, 10 power minus 11 plus 24 plus 3, 27, plus 3, 3, 6, 6, 12. So when this 10 power 12 comes into the numerator, it will become minus 12. Implies F is equals to 2.22 into 10 power 27, 23. So it is 10 power 4. So F is measured in newtons. So this is the force of attraction between the earth and that body, which is having a mass 2000 kg. In other way also you can do this. F is equals to G capital M small m by r square. So in place of G capital M small m, where capital M is the mass of earth and r is the radius of earth, I can keep small g, because just now we derived the relation between small g and capital G, where small g is equals capital G capital M by r square. So this can be written as F is equals to small g into m, implies F is equals to small g, this is 9.8 into m, m is 2000 kg, so into 2 into 10 power 3 by calculating. So in the previous section, so we have taken approximate values, like in place of 5.97 I kept 6, in place of 6.3 I kept 6 again. So here also if you keep instead of 9.8, if you keep 10, it will become F is equals to 2 into 10 power 4 Newton. So in this way also you can do the problem. Let's try one more problem. The mass of two bodies are doubled and the distance is halved. How does the gravitational force change? To do this, let us consider two bodies. The mass of the first body is m1 and mass of the second body is m2. Let the distance is r. Initial force of attraction between them, let it is F. So I can write F is equals to G small m 1 m2 by r square. And in second condition, the mass of two bodies are doubled. Let the mass of the first one after doubling, let it is capital M1, given it as it is doubled to the initial one, so 2m1. In similar way, let the mass of the second body is m2, capital M2, and this is nothing but 2 into small m2, because these masses are doubled and the distance is halved. Let the distance in the second case is r, and this is halved. Halved means the initial one is r by 2. I hope you understand. So while doing these problems, you have to read the problem thoroughly and you have to understand. The masses of two bodies are doubled. The initially it is m1, doubled means 2m1, and second one is m2 and doubled is 2m2, and the distance is halved, means r is equals to small r by 2. Now the new gravitational force. The gravitational force in this second case, let it is F nu is equals to G. This is a universal gravitational constant which cannot be changed. M1 in place of capital M1 and capital M2 by capital R square. Okay. Now Fn is equals to nu is equals to capital G, universal gravitational constant, and capital M1, which I can write 2 small m1. Second one is capital M2, I can write it as 2 small m2 by capital R square is there. In place of r, I can keep small r by 2 because the distance is halved, whole square. Implies Fn is equals to G 2 into 2, this is 4 m1 m2 by, here you must be very careful, r square by 2 square. By 2 square means by 4. Okay, this 4 comes to numerator. So Fn becomes G m1 m2 by small r square. 4 into 4, this is 16. I can rewrite the equation like this: Fn is equals to 16 of G small m1 small m2 by r square. What is G small m1 small m2 by r square? The initial force of gravity. Fn becomes 16 of F, where Fn is a new gravitational force between the bodies whose masses are doubled and distance between them is halved, and F is the initial gravitational force between the bodies. Means after doubling the masses and making the distance half, the force of attraction between them increases 16 times. This way, by this we have to solve these type of problems. So whatever may be the condition given, masses are doubled. Here in this problem, masses are doubled. In some other problem, masses may be halved or distance may be doubled. In some other problem, one mass is tripled and one mass is doubled, and the distance made it half. So you can apply the condition and you will get the solution.